Okay, I'm going to measure this particular one, which is, I do know it should be from the schematics. It's a surface mount capacitor, ceramic capacitor. Should be in a region of about 1000 picofarad, which is 1 nanofarad. Let's measure it. Okay, let me just measure it. Let me just connect it up. Okay, and see, sorry, let me just change the higher frequency for this particular series. Okay. And then see, okay, it's exactly 1 nanofarad, 0.199. Now, 0.2 decrement factor, the number on top of the display. Okay. Now, let's measure even the smaller one. Okay, over here. Okay. Let's measure it. Okay. That's about 917 nanofarad. Okay, because of the tolerance and so on, yes, it does give me a bit bigger decrement factor, but the value is more or less the right one, okay? And I would say the capacitor is in very good condition, okay, from experience and so on. Of course, as I explained, you have to know your electronics and bit of experience in doing this type of measurements. So by using the tweezer and this instrument, not the one that has got a display, because that doesn't give me that accuracy like this particular one will, which is about maybe 5 times more accurate and faster and more reliable, let's put it that way, should I say. Nonetheless, this way I can go from capacitor to capacitor, whether it's a big or small, I can measure, I can put, let's see, this particular one, okay, this one here measures like 17 microfarad, and I do know that this one should be about 20 microfarad. So it's a bit more out of tolerance type of thing. Now, how do I know if the capacitor is really okay or not? Oh, well, this just gives me an indication. Although it's a very accurate instrument, still it does not give me with 100% certainty that this capacitor that I've just measured, although I'm looking at a decrement factor, even a Q factor type of thing, it does not tell me that this capacitor is okay. So how do I determine? Very simple, okay? That's, of course, I can remove it and I can measure it, and then yes, I will get a definite answer. It's okay or it's not okay. It is within the factory specs or it's not within the factory specs. So I don't want to strip it because maybe I've got 100 of these capacitors over here. There's no way. I'm going to need a month to be able to remove and to fit and so on. Plus, you might damage them in a process of sort of removal and refitment in such a quantities. So how do you do it? What do you do? Where it's okay, let me show you on one electrolytic one the discrepancy. If you look at it over here, this particular cap, okay, that's a 4.7 microfarad, okay, and it's a 450 volt. Now, according to manufacturer, any capacitor manufacturer, you're supposed to measure the capacitor in circuit, okay, not to be able to interfere, or even off circuit. You're supposed to measure it, what you call it, at the voltage, specifically if it's, per prescribed and recommended wherever frequency. So this is 4.7 microfarad. Sorry, where's it? Yeah, this one, yeah, that's 4.7 microfarad. Now, according to this chart, yeah, I should measure it, if you look at it over here, I should measure it at 100 kilohertz with the reactance maximum up to 0.5 ohm. Okay, I'm not going to go into explanation of the graph, but the moral of the story is manufacturer recommends that this particular capacitor should be measured with the 100 kilohertz at 100 kilohertz frequency in order, and I must not exceed, because now again you must know your electronics. I got the transistors, I got the optocouplers, I got the TL431, sort of reference regulator and so on, I should not exceed certain voltage. So how do we measure it? Very simple, okay? It's 100% accurate and gives me with 100% certainty that this capacitor is okay or not. Let's measure it with this instrument and see what it gives us. Should be 4,7. Let's see what it gives us. Okay. Gives us, okay, 4,5 microfarad. Okay. Let's measure this one here. Sorry, let me just do this. Okay, 3,5. Okay, that's not bad. Okay, so it measures more or less okay. Okay, but I shouldn't measure it at 1 kilohertz. I should measure it at 120 hertz. So let's try, and you'll see we get a different measurement. Slightly different. Can you see? 8,8 microfarad. Okay. Now, that just indicates that any capacitor, that's why manufacturer specifies the frequency that you have to measure it. First measurement, I measured it at 1 kilohertz, showed me 4,7 microfarad. Okay. Then I measured it at 120, it gives me 8,8. Now, according to manufacturer, 4,7 microfarad, I should measure it at 100 kilohertz, if you look at it over there. Okay. Actually, even more than 100 kilohertz when you actually look at it, type of thing. But nonetheless, 100 kilohertz would be 99%, it will give me 99% accuracy. So for this specific capacitor, I cannot generate 100 kilohertz with this instrument. There is no portable instrument, or this ones with the display over here, that are capable that you can change, say, from 1 kilohertz or from 100 hertz or from 10 hertz to 100 kilohertz. So how do you do it? Very simple. Okay. Now, if you look at it, let me just shift the camera again. Now we go to the second way. Okay. We use a special jig that we made, okay, which we got all these instruments over there. All these instruments over there connected already together, okay, and eventually I end up, let me just, sorry, I'm trying to operate the camera and to talk, and eventually I end up only with 2 probes, only with these 2 probes, and now I actually inject. Sorry, let me just again shift the camera, okay, and now I actually inject specific voltage. I inject specific voltage on this particular capacitor, what the factory recommends, and of course I would inject 100 kilohertz, and I would inject probably about 50 millivolta maximum coming out of these probes, or maybe even less than 50, maybe 10 millivolta. Depends on the capacitor and what is the factory recommended sort of voltage and things like that to be measured at, and so on. And that way I will be able to, with 100% accuracy, measure the actual voltage which I would display onto my 179 fluke, and use that measured voltage against the actual graphs, against the graphs, and get what reading I should get on the actual fluke type of thing. What resistance it will actually show me, that type of thing. Okay, so whether it's a bipolar or non-polar, the procedure would be the same. So by using these graphs, I would be able to ascertain 100%, with 100% accuracy, whether this capacitor is okay or not. And that's why I say these type of instruments, although this is top-notch instrument, okay, very accurate, maybe 10 times, 5 to 10 times more accurate than the the ones with the LCD display, the portable ones. Yes, it's more of a gimmick type of thing compared to this. But even this one, does not give me 100%. So then I resort to my second way. Even if I'm not happy and I'm having any doubts with my measurements, second measurement type of thing, with this, okay, let me restart from scratch. In other words, imagine it's a big PC board, and so I would go with this instrument quickly and ascertain and more or less. And the ones that pick up slight discrepancies or I'm not happy with from experience, I would just mark it with a cocky pen and then come later on and do the measurement, more precise measurement with my second sort of method. If I'm not happy with the second method, then what I would do is I would actually, where is that capacitor? I would actually remove this capacitor, okay? I would remove it physically, okay, because it's only one off. It's not like 60 of them, okay? And then I would probably do the leakage test with this particular instrument and jig, and I would, like this particular cap is 4,7 450 volta, so I would use this particular jig, okay, which I can generate that 450 volta, and I would see the leakage current on my instrument. And every manufacturer gives you again the charts of the leakage current that that particular capacitor for that voltage would have. If it's a lower voltage capacitor, immaterial of the value but lower voltage, then I would use this particular sort of that I can go into nanoamps, microamps type of thing, measurements, leakage actual current through the capacitor, whether it's a polar, non-polar, and so on. Makes no difference. And that is basic, and that way I would be with 100% guaranteed that I would be able to say this particular cap is definitely confirming to, or this is breaking under the voltage, or whatever the case may be. So in a nutshell, basically I explained a factory designed instrument, and as I said, yes, there is the instrument. A lot of people, they like them because they're fancy and they whatever. But I'm against them. The reason why, because does not give me that accuracy and versatility and voltages and frequencies that I can vary on this one, and facilities that this one can give me, and stability. Okay. As I said, I've got quite a few different gauges that you can connect to the instrument and things like that. But nonetheless, because of the not enough time in this video, and it's I'm not going to go into details. With this, I would quickly measure problems, go to the second way, confirm on the problem ones that I picked up. Then, if I still don't feel happy, then I remove that particular component and I do it. Now, exactly the same thing applies to the actual resistors. Okay, whether it's a resistor like this, or whether it's a inductor like this green component over here, like that green component, it makes no difference. It would apply exactly the same. And why I like my method, the other method with the other instrument, let me just, with the other sort of instruments on the side of the, sorry, difficult to lift the camera. Well, I like that particular method because not only that I can vary injected voltage into the circuit, not to trigger other sort of components so they can interfere with the measurement. Also, I will not be able to blow some sensitive components. So in a nutshell, this is only 3 ways that I'm showing you quickly. Of course, we got up our sleeves different other 2 methods that we actually use, but as I said, the scope of this video was to just show you the 3 different ways that we can measure, whether it's a capacitor, electrolytic, non-electrolytic, whatever type of a cap, resistors, or any inductor in circuit, and with what, or out of circuit, and with what degrees of accuracy can you actually measure. And with my 3 methods, I can do whatever I want. I can do whatever measurement I want. Any manufacturer's specs I will meet, because I'm able to generate with my own sort of way. I don't rely just on, do certain sort of, and in electronics you cannot just have certain sort of instrument to do certain measurements. You must be able to, because you don't know what you're going to encounter. So from that point of view, yeah, I think I've sort of spoke enough, and I hope I explained it well. And maybe in the next video I will do another 2 ways of actually measuring in circuit, even transistors, like MOSFETs, and the other sort of with a fair amount of accuracy type of thing. All right, on that note, I say thank you for watching Bato's Radio and TV demo and the explanation on the measurement of resistors, capacitors, and inductors in circuit and out of circuit. Thank you.